In this video, we'll begin our discussion of the analysis of variance, or ANOVA for short. First, we're going to talk about an introduction to experimental design, which is often connected with analysis of variance. These two concepts really have nothing to connect them except that analysis of variance is often the analysis used within an experimental design, and we'll briefly discuss that. Then we're going to talk about analysis of variance within a completely randomized design, the multiple comparisons procedures. Then we'll maybe talk some about the randomized block design and factorial experiments as we have time at the end of this section. So statistical studies, there's a lot of ways to classify them, but two common ones that are very oversimplified are experimental designs or observational designs. In experimental designs, you can look at this one of two ways, both of which are the same. One is to look at the factor, the other is to look at the individuals or the experimental units or the people in the study. So looking at the factors, we could say that we're controlling a factor so that we can figure out how it works. So thinking about this more practically, let's say we have two advertisement methods. I might pick which advertisement method I want to use with which person. So that's one way to think about this, is that I'm controlling the advertisement method. From a person perspective, and again, this is the exact same thing, just said a slightly different way. From a person perspective, you'll also hear that individuals are randomly assigned to two groups. So let's say instead of assigning the advertisement method to a person, instead, I look at this as assigning the different people to the advertisement method. Again, ultimately, it's the same thing, but the idea is that with an experiment, I have that level of control. So I can look at person A and say, okay, you're going to get the first advertisement method, and person B is going to get the second advertisement method. So I have the ability to change what individuals get. So that's the core of an experimental study. And I'll go one further and say that this happens randomly. So we don't want this to happen just haphazardly, like, yeah, I could have controlled it, but nah, just let whoever get whatever advertisement method. In an experimental study, typically we use random assignment. And again, you can look at this as random assignment of factor to experimental unit, or person, advertisement method to person, or you can look at this as random assignment of experimental unit to factor. Now, contrast that with an observational study where this says no attempt is made to control factors. Often we do observational studies when it is impossible to control factors. So it's not really about an attempt or not. It's about whether or not you can or not, very often. So observational studies, we really just observe data that are already collected often is how this ends up working out. What's interesting is that experiments and observations lead to different kinds of conclusions. You may have heard the phrase correlation does not equal causation, and I guess this wouldn't be a real statistics class unless we said that or reminded you of that. But observational studies can only lead to correlational results. Experimental studies can lead to causational results. And if you've ever heard the phrase necessary but not sufficient, that's what experimental studies are for cause and effect relationships. You'll see that it says this is easier to establish in experimental studies. The thing is, if you do an experimental study, that doesn't make the results causal necessarily. You can still mess up experimental studies. That is a necessary condition for establishing cause and effect relationships for many researchers in how they consider establishing cause and effect relationships. Now, analysis of variance is an analysis type, so it's kind of weird to talk about this in the same context as experimental design. The reason we do so is because analysis of variance looks at different groups and analyzes the different groups in their continuous outcome. So for analysis of variance, think like a t-test. Our previous two sample t-tests, we had like a male group and a female group, and then we compared them on some outcome like height or weight or GPA, some continuous outcome. So we had sex, our independent variable that was categorical with two groups, and then we had GPA or height or weight, some continuous outcome variable, and then we wanted to compare the different sexes on that continuous outcome. So that's the idea behind a two-sample t-test. Analysis of variance is literally exactly the same thing, except now we can have more groups. So let's say I want to look at the intelligence of people who like different pizza toppings. I want to compare pepperoni pizza lovers to sausage pizza lovers to anchovies pizza lovers, because clearly one of those groups is going to have way less intelligence than everybody else. Just kidding. If you like anchovies, well, let's be honest, you're kind of weird. But outside of that, it's okay. You're probably just as smart as everybody else. Or are you? But pizza, pepperoni, sausage, and anchovies, we want to compare these. And we want to see, does one of these groups have a higher outcome than the other? Now, previously with a t-test, we could just have two groups. ANOVA lets us have 2 or 3 or 4 or 5 or 6 groups. So that's the reason we like ANOVA. Later on, we'll talk about ideas like correlation and regression. Typically, in experimental study, we don't have things like that because in an experimental study, remember, we have a controlled factor that we can assign to people. So we can put people into groups. What this ends up meaning is that an analysis that can handle different groups is a really, really useful one and very highly connected to experimental studies because an experimental study is a study where we can put people into groups randomly. And the analysis of variance is the analysis where we can analyze different groups. So the only reason we like analysis of variance over a t-test is this can handle any number of groups instead of just two groups. But otherwise, we'd really like t-tests for experimental designs as well. So we like the ANOVA. Again, ANOVA is analysis, experimental is a study design. So these are different concepts. Analysis of variance is a type of statistical analysis. Experimental design is a way to set up a study. So they're very, very different concepts, but that's why they relate. Is if I'm doing an experimental design, I'm assigning people to groups. And analysis of variance is the statistical way to analyze individuals that are grouped when they have a continuous outcome. So we're going to look at a couple of different types of designs. Again, we may or may not get to the last two, but the first one is the completely randomized design. And in a completely randomized design, again, you're randomly assigning either the group to participant or the people into the different bins. Both of these are the same concept. They're just said two different ways. I'll talk about them. I'll try to use both terminologies. So if you're used to one, you'll hear what you're familiar with. But typically I think about we have a bunch of, let's say, 3 different groups, and then I randomly assign people into the group. So typically I think about person A gets randomly, I pick 1 to 3, I randomly pick 2, person A is in group 2, and then I randomly assign people to groups is how I tend to think about it. All right, so let's talk about some terminology and some definitions, and this is important because I'm going to use these terms pretty often throughout this section, and it's important that we're on the same page as it regards these terms. So the first term that I'm going to use very often is factor. So I want to give you a few examples of factor, and if you need to, pause the video to jot these down. These are probably worth writing down on the margin of your notes if you're looking at a printout, or in your notebook if you're taking notes the old-fashioned way. So a factor is the variable that can be broken up into groups, and I'm going to give you a ton of examples on this. So let's say we looked at males and females, and we're looking at how male and female differ on their heights. So a factor is going to be the variable sex or gender or whatever you want to call the overall variable for male and female. And then the group male and the group female will each be called the levels of that factor. All right, let's do another example. Favorite pizza topping and its relationship with intelligence. So I've got favorite pizza topping. That is the factor, the big picture kind of description of that variable, pizza topping. And then the levels of pizza topping are going to be pepperoni, sausage, anchovies, the different pizza toppings you can have. Another one, let's see, different people's eye color on how social they are in social situations, as measured by a social situational scale that's continuous. So in this case, eye color is going to be the factor. Again, that's the single kind of term that describes the variable. And then the levels are, well, what eye colors can you have? Well, I can have green, I can have blue, I can have, oh my gosh, there's more colors than green and blue, right? Brown, I can have brown. I can have, I don't know, orange and gray, and I'm sure there's some other weird ones. I don't know. Okay, anyway, so that's factor versus levels. And you're going to hear me talk about that all the time. Now, they'll say a treatment is a level of a factor. So all it's saying here is, let's say the factor is drug. Or like let's say I've got my old marketing method and my new marketing method that's considered the treatment, versus the old marketing method, which is considered the control. So the factor would be marketing method. That's the big picture description of what's going on. And then the levels would be control, the old marketing method, and treatment, the new marketing method. So that's what they mean when they say treatment is a level. Again, levels are just the different things that the factor can take on. So pepperoni, sausage, anchovies for the factor of pizza topping. And if I'm looking at a big picture thing like marketing method, or in a medical context, drug, quite literally the treatment, right? So drug, I give half the people a placebo, I give half the people a treatment. Then in that case, drug is my overall variable name, or the factor name, and then the levels are treatment and control, or treatment and placebo. Now, you heard me use earlier the idea of experimental units. So these are the objects in the experiment. So often when you hear experimental units, think people. So like if I'm doing a drug test on people, people are the experimental units. It's what am I analyzing in the experiment. Sometimes you'll see a distinction between experimental units and measurement units. I'm not going to go into that. That would be if we have clustered data. So we're just going to treat it as if we're doing the experiment on the subjects directly. Again, what does that mean for the purposes of our class and for practical purposes? For practical purposes, what we mean is the experimental units are what goes into a treatment. So like we've got our factor of pizza topping, pepperoni, sausage, and anchovies. And then I've got 15 people whose favorite pizza topping is pepperoni, 10 people whose favorite pizza topping is sausage, and one person whose favorite pizza topping is anchovies. And so the experimental units are the people. Another way to think about experimental units is, where am I collecting my data? So like if I wanted to do this study, experimental topping and GPA or IQ or something, where would I collect the data? Well, I'd go out and ask people, what's your favorite pizza topping and what's your IQ? That'd be kind of an interesting question. But I'd go up and ask individual people. So those individual people are the units of the experiment. The last way to think about this is what is randomly assigned. So if you look at random assignment as like people to different drugs or something like that, then experimental unit would be random assignment. Sometimes experimental units, like in an industrial setting, experimental unit might be let's say I want to run an experiment on the tensile strength of different pieces of metal. So I bend a bunch of pieces of metal to see how much bending it'll take before they break. Well, the experimental unit would be each of the different pieces of metal. So that might be an experimental unit in that context. Let's say I want to implement a whole bunch of different policies at a school to see if different schools around the country react differently. Well, in that case, experimental unit might not be the teachers or the students. Experimental unit might be a whole school taken all together. So that's the idea of an experimental unit, is what are we doing experiment on, and what are we randomly assigning the treatment to within a randomized design. All right, so the last piece of definition here is the completely randomized design. This is an experimental design where we're randomly assigning. And again, you can look at this as randomly assigning the treatments to the units or randomly assigning the units to the treatments. It really doesn't matter how you look at this. Both of these are kind of the same, but ultimately you're using some kind of randomizer. We tend to use computers these days, but heck, back in the day, people used to flip coins or roll a die or whatever to randomly assign or randomly pair up these treatments and experimental units. Now, because I do a lot of social research, you'll hear me say experimental units as people. Very often in surveys, that is what our experimental units are. So I tend to lean towards that, and I apologize. But for the purposes of this lecture, because I don't mean to confuse you, whenever you hear people as a general term, when I'm talking about some kind of a design factor, think about experimental units if you want to. Frankly, it's good. This is like a good definitional term to know, especially if we do branch out and we cover an example where the experimental unit is not people, so that we have a term. You'll see it abbreviated EU, but it's nice to have a term to come back to call these things. But very often it's just going to be people, and we'll just use people in place of experimental units throughout because it is so common, an experimental unit within social research designs. All right, well, this is our terminology. This is kind of our background and our starting place. In the next video, we're going to jump into how do we actually do this analysis of variance and interpret it.